Good afternoon. This is Patrick Ortiz, CEO of Crown Hill. I'm a mechanical engineer, and basically what I've done today is I'm gonna give you a little behind the scenes of the concepts and designs and how things work around the factory for making motors. So, growing up, during school and all that stuff, I used to always work on my car, work on my motor, build my motor. Plenty of cars, plenty of motors, blown up plenty of cars, blown up plenty of motors. In the little world of car building and modifying and stuff like that, what a lot of people do is they like to I don't know what to do with my hands. They like to swap different motors into cars, and that was one of the things I did a few times. And it's basically to get a little more power, use a motor from a bigger car, or just to get more power out of your car. So what I've done is I've pretty much tried all my favorite motors that I've wanted to do. So I kind of got bored. So what I wanted to do is start designing my own motors with my own specifications to apply to my own field of driving. And that's basically what I did today. So I started off with a four-cylinder motor and single cam four-cylinder motor, just something simple to show you guys how it works. So we're just going to dive into that, and then we're going to see how they're made in the factory after that. So one of the most important parts about engineering and motor and stuff is the software you use. So for this, I'm using CATIA version 5, and basically it's a CAD. It's an engineering tool. You just design literally whatever you want. And this is kind of a fast forward view because it really takes a long time to do. Now, for this, there's tons of math involved, a lot of mathematical equations you have to find out to figure out the right type of arches, the right angles for things, to find the right circumference of circles and stuff like that. So luckily for me, I was fortunate enough to get my education at UCF. I got a bachelor's degree in mechanical engineering, followed by a master's degree in business. So after working for Nissan for a few years, I said, I'm making pretty good money, so let me start my own company. Crown Hill Engineering. So what I learned from them, I applied to it now, and I just improvise more. So now the motor is pretty much ready to be put together. So what I'm doing right now is finding the coordinates for everything, so everything can pretty much just drop in place, and that's pretty cool. That's a pretty cool feature about this system. You can just fit everything, fit all the nuts into the bolts, fit all the bearings into the shafts and stuff like that. So everything just kind of goes right into place when you're done designing it. Now the motor is pretty much up and running. It's fully functional. You can see the pistons moving up and down to spin the crankshaft. You can see the valves move up and down. You can see the camshaft rotate. Let me take off the valve cover so you can get a better look. Right there you see the cams spinning for the intake and the exhaust valves. And now you get a better look of the pistons spinning the crankshaft, so it can actually give the rotation to the wheels and not solved by the drive shaft and the transmission. And that's pretty much the designing and concepts of how to get a motor fully operational in the CAD system. Now we're going to take a look at the factory and see how they're actually made in real life. So this is where all the magic happens at Crown Hill. After we're done with all the modeling and designing on the computers, we're actually able to get the virtual printings of them and then put them on our systems for the machine so they can actually create the actual product in real life. Engine components are housed in what's called the engine block. It arrives over here in Crown Hill partially made. So here we finish it off by machining the cylinder bores, the holes in which the pistons move up and down. Lubricating oil will cling to the grooves in this pattern, so it would enable the pistons to move smoothly up and down. After machining, the engine block travels upside down to the engine assembly line, and basically over here we have a little machine that scans the traceability code. It's basically a barcode that enables the factory to track the block through every stage in production. As the engine block travels down the line, we have devices that ensure each component is installed properly. The crankshaft is a bar that's rotated by the up and down motion of the piston. As it turns, it transfers power to the transmission. The crankshaft starts out as roughly just a steel block, basically. So from station to station, it's passed down and it's carved until 20 stages later, where it's actually fully formed and it's an actual crankshaft. Now we install a steel disc with teeth called reluctor ring. It's basically heated and then pressed onto the crankshaft. As it cools, it shrinks to a tight fit. This ring helps time the combustion cycle. As it spins, its teeth pass through the front of a sensor which reads the crankshaft's position, and it tells the engine to fire the spark plugs at precisely the right moment. The machines and tools that we have here literally cost millions and millions of dollars. So my advice to you future engineers is, if you have a solid idea and you feel like it's great, don't be afraid to take out a loan and invest your money into that idea. It's only going to propel it forward. And that's what I did. There's no way I'd be able to afford half, even a fourth of these machines if it wasn't for a loan with just a regular job of engineering at Nissan, making $100,000 a year. Odds are you're not going to be able to afford millions of dollars worth of equipment with just a job that you get out of college for engineering. Continuing with the manufacturing, now we're ready to install the pistons. The pistons are made out of aluminum. Robots install them into the cylinder bores of the engine block. A steel connecting rod attaches each piston to the crankshaft. Now workers can close up the back of the engine block, and then a robot just applies sealant to the rear cover. And then it's bolted on manually with a torque called it's a multi-spindle torque gun. And that basically just torques it up to spec. On a different line over here, we have the heads of the cylinder block. This robot puts sealant on the spark plug tubes before inserting them into the head. The heads cap off the cylinder bores, and they provide each cylinder with a spark plug and 4 valves. 2 for fuel mixture, and then 2 for releasing it to the exhaust. The black tubes running front to back of the camshafts, those are the components that open and close the valves. So there are 4 per engine if you have a V6 or a V8, and then 2 if you have a straight 6 or just a 4-cylinder dual cam. So over here we pretty much have the final stages of adding the pulleys and adding the manifolds, and then finally what we do is we spin the engine to make sure all of the components are working correctly, and then they are off to their vendors.